My friend, this is a really elegant geometry problem because it looks complicated at first, but once we introduce a couple of variables, everything falls into place beautifully. Let's work through it together very carefully. We want to find the area of rectangle x, y, z. Now the first thing I'm going to do is assign variables to the unknown radii. Suppose the radius of the quarter circle is r. Since the quarter circle starts at the top corner and reaches the bottom side at point M, the height of the rectangle, which is wx, must be equal to r. Also notice that the horizontal distance from x to m is another radius of that same quarter circle, so xm is also equal to r. Now let's introduce another variable. Let the radius of the semicircle be s, and let O be the center of that semicircle. Since MO is a radius, MO equals s. The remaining portion of the diameter on the right side is another radius, so that segment is also s. Therefore, the entire width of the rectangle xy is equal to r plus s, which simplifies to r plus 2s. Now, let's write the area of the rectangle. Area equals height multiplied by width. The height is r, and the width is r plus 2s. So the area becomes r multiplied by the quantity r plus 2s. Let's expand that expression carefully. R multiplied by r gives r squared, and r multiplied by 2s gives 2rs. Therefore, the area of the rectangle is r squared plus 2rs. Keep that expression in mind because it will become very important in a moment. By the way, my friend, if you're enjoying this problem so far and you like these beautiful geometry shortcuts, make sure you hit the like button, subscribe to the channel, and leave a comment telling me whether you spotted the key idea before I reveal it. Now, let's continue. We are told that the slanted segment from point X touches the semicircle at point T, and its length is 12 units. Notice something very important here. In any circle, a radius drawn to the point of tangency is always perpendicular to the tangent line. This is a fundamental property of circles. Since OT is a radius and XT is tangent to the circle, angle OTX is a right angle. That means triangle XOT is a right triangle. Let's identify the lengths of its three sides. The tangent segment XT is 12. The radius OT is S. And the distance from X to O is equal to R plus S because X to M is R and M to O is S. Since we have a right triangle, we can apply the Pythagorean Theorem. The theorem tells us that the square of the hypotenuse equals the sum of the squares of the other two sides. And therefore, XO squared equals XT squared plus OT squared. Substituting the values gives the quantity r plus s whole squared equals 12 squared plus s squared. Now let's expand the left side. The quantity r plus s whole squared becomes r squared plus 2rs plus s squared. On the right side, 12 squared is 144, and then we still have plus s squared. So we obtain r squared plus 2rs plus s squared equals 144 plus s squared. Notice what happens here. We have s squared on both sides of the equation. Since the same quantity appears on both sides, we can subtract s squared from both sides and cancel it completely. That leaves us with r squared plus 2rs equals 144. Now pause for a second and compare this result with the area expression we found earlier. Remember that the area of the rectangle was r squared plus 2rs. But we have just shown that r squared plus 2rs equals 144. and therefore the area of the rectangle must be 144 square units. That's already the answer, and what's beautiful is that we never had to find the actual values of r and s individually. The geometry gave us the area directly. Now let's also look at a second elegant approach, because it reaches the same answer even faster. Again, let the radius of the quarter circle be r, and the radius of the semicircle be s. We know that xt is a tangent segment of length 12. There is a famous theorem called the tangent secant theorem, sometimes known as the power of a point theorem. It states that if a tangent and a secant are drawn from the same external point, then the square of the tangent length equals the product of the external part of the secant and the entire secant length. Here, the tangent is xt, and the secant lies along the bottom side of the rectangle. According to the theorem, xt squared equals xm multiplied by xy. We know that xt is 12, so xt squared is 144. We also know that xm equals r, and the entire width xy equals r plus 2s. Therefore, 104 equals r multiplied by the quantity r plus 2s. Expanding the right side gives 144 equals r squared plus 2rs. But notice again that r squared plus 2rs is exactly the expression we obtained for the area of the rectangle. Since area equals r squared plus 2rs, and r squared plus 2rs equals 144, the area must again be 144 square units. Both methods lead to exactly the same result, which is always a good sign that our work is correct. So, the final answer is 144 square units. My friend, this problem is a wonderful reminder that sometimes the smartest strategy is not to find every unknown quantity. Instead, look for the expression you actually need and try to connect it directly to the information given. If this clever geometry trick was new to you, don't forget to like the video, subscribe for more challenging math puzzles, and leave a comment telling me which method you preferred. The Pythagorean Theorem method or the tangent secant theorem method. The final area of rectangle WXYZ is 144 square units.